of grade 10. Today we are going to start a new unit, unit 4, the unit of mechanics. First of all, we are going to start with chapter 14, description of motion. In this chapter we are going to talk about four main ideas: the definition of motion, the position vector, speed and velocity, and the acceleration. First of all, we are going to define motion. The motion is defined as the change of position of a body relative to a reference position. As shown in this picture in here, the car was initially at the reference point, which is the reference position A. Since the position of the car changed from A to B, we say that this car is in motion, since the position of the car is changed. Rest or motion is relative, which means that the same object may be at rest with respect to a certain observer and in motion with respect to another. For an example, the trees outside the bus are in motion with respect to the passengers inside the bus, while they are at rest with respect to the passengers outside the bus, which means that the same body may be at rest or at motion depending on the observer. The trajectory. The trajectory of a moving object is the path described by this object during its motion. This trajectory may be in three conditions. The first one is rectilinear. The trajectory is said to be rectilinear if the center of gravity of the moving body is a straight line, which means that all the points are collinear to each other. When this car moves in a straight line, this means that the trajectory is rectilinear. Or the trajectory could be curvilinear. The trajectory is said to be curvilinear if the center of gravity of the moving body, which is the ball in this figure, are not collinear to each other, which means that they are moving in a curve. Last one is the circular. The circular trajectory is when the center of gravity of the moving body is moving in a circle, so we say that this trajectory is circular. Displacement. Displacement is a vector quantity, which means that it has a magnitude and a direction. For an example, the displacement, first of all, is the difference between the initial and the final position of a body. As shown in this figure in here, the box was initially at a position x0. Since it's under motion, so its position is changed and it becomes at the position xf. The displacement is said to be the difference between the initial and the final position of this body. So delta x, which is the displacement, is equal to xf, the final position of the body, minus xi, the initial position of the body. For an example about displacement, we want to determine the displacement of the teacher. This teacher was initially at the position 1.5 meter. It then changed its position into 3.5 meter. Since the position of the teacher is changed, we say that this teacher is in motion. To find the displacement of the teacher, delta x is equal x fine in the final position minus xi, the initial position, which is 3.5 minus 1.5, so delta x is equal to plus 2 meter. So the magnitude of the displacement is plus 2, and since it's positive value, this means that we are moving in the positive x-axis direction. So we know that the motion is to the right. That's why we say that displacement is the magnitude and the direction, so that it's a vector quantity. The final idea we are going to talk about is the air table. The air table is an equipment that provides a surface where pucks can move almost without friction. This figure in here shows the equipment which is called air table, and those two are called the pucks. Those pucks, when they move along the air table, they are moving almost without friction. This air table can be used to study any motion of a body by locating different positions separated by equal time value between them, called the time constant, which is represented by this symbol tau. So using those pucks and the air table, when the pucks moves on this air table, we can locate different positions of the pucks on a paper so that we will obtain this figure in here. This figure represents the different positions of the puck in a way that the time separating any two different positions of this puck is equal to the time constant, which is tau. This drawing in here, or this location of the puck's position, allows us to study the motion of this puck.